In today's session, we are going to solve a few word problems based on quadratic equations. Let us take a look at the first question. Find two consecutive odd integers whose product is 195. So we have two consecutive odd integers. Now two consecutive odd integers always differ by a value of 2. So if I consider the first odd integer as x, the next odd integer is going to be x plus 2. So I can say consider the odd integers that are consecutive to be x and x plus 2. Of course, you could also consider it as x and x minus 2 because you could consider the larger odd integer as x and the smaller one as x minus 2. But here I have considered x and x plus 2, whose product is 195. So the product of these two integers has to be 195. So the equation that I can build is x multiplied by x plus 2 should be equal to 195. Opening up the brackets, x into x becomes x square, x into 2 becomes 2x is equal to 195, and therefore x square plus 2x minus 195 is equal to 0. Now I have to find two numbers whose product is 195. So let us start splitting 195. 195 can be written as 39 5s are, but that doesn't give me a sum of 2. I can divide this by 3, so it becomes 13, and multiply 5 by 3, it becomes 15, and I think this is the right combination. The sum is positive, which means the larger number is positive and smaller one is negative. So therefore this becomes x square plus 15x minus 13x minus 195 is equal to 0, and therefore x into x plus 15 minus 13 into x plus 15 is equal to 0, and therefore I can say that x minus 13 into x plus 15 is equal to 0. Therefore x is either positive 13 or x is negative 15. Now over here they have said that they are integers, so even negative numbers are allowed, and there is no mention of the number being positive, right? So now both values of x are allowed. Therefore, x could be either 13 or negative 15, which means x plus 2, that's the next integer, odd integer. So x plus 2 would therefore be 15, or negative 15 plus 2 would be negative 13. And therefore, the two consecutive odd integers are either 13 and 15, that's one possibility, or negative 15 and negative 13. A quick check, product of these two is 195, so that condition is satisfied, and they also differ by a value of 2, and they are odd integers. So both these combinations satisfy the given requirements, and therefore they form the answer. Pausing for a minute before I move on to the next one. Moving on to the next question. The sum of squares of three consecutive even integers is 200. Find the integers. So the sum of squares of three consecutive even integers. So now we are talking about three consecutive even integers. So I will say let the consecutive even integers. Now again they are consecutive, so one after the other, and they are even, so they differ by a value of 2. So let the consecutive even integers be x. The next one is going to be x plus 2 and x plus 4. Of course, you could also take the integers as, you could also consider the integers as x minus 2, x and x plus 2. So you could solve the same problem taking the this particular combination as well. I am going to solve it using x, x plus 2 and x plus 4. Now the sum of their squares, that means x square plus x plus 2 the whole square plus x plus 4 the whole square, the addition of all their squares is 200. And now I can simply adopt a plus b the whole square in both the brackets. So x square plus this expansion is going to be a square plus 2 times a times b plus b square, and x plus 4 the whole square is going to be a square plus 2 times a times b plus b square is equal to 200. So now x square plus x square plus x square is 3x square. 4x plus 8x is 12x. And 4 plus 16 is 20 is equal to 200. So therefore 3x square plus 12x minus 180 is equal to 0. Dividing throughout by 3, I get x square plus 4x minus 60 is equal to 0. And now I can go for factorization. I believe if I factorize, I will get x plus 10 into x minus 6 is equal to 0, which implies x plus 10 is 0 or x minus 6 is 0, and therefore x is either negative 10 or x is positive 6. And because x is negative 10, so let's take first case, case 1. Case 1 is where x equals negative 10, and therefore the even integers would be x is negative 10, x plus 2 is negative 10 plus 2 negative 8, and negative 10 plus 4 is negative 6. That's one case. And the second case would be x is positive 6, which means that the integers would be, so even integers would therefore be, x is positive 6. The next one is x plus 2, that's positive 8. And x plus 4 is positive 10. So the integers are 6, 8 and 10. So again I'm going to pause for a minute and let you take a look at the solution before moving on. Moving on to the next question. Find two numbers whose sum is 8 and the sum of their reciprocals is 8 by 15. So I would simply start off saying that let the numbers be x. So if the first number is x, then out of 8, one number is x, and therefore the other number is going to be 8 minus x, right? So the sum of these two numbers is 8, and the sum of their reciprocals is 8 by 15. That means 1 by x plus 1 upon 8 minus x is equal to 8 upon 15, right? So the reciprocal of x is 1 by x. The reciprocal of x is 1 by x, and the reciprocal of 8 minus x is 1 upon 8 minus x, and the sum of these two reciprocals is 8 upon 15. That is the condition given to us. So this is how I framed the equation. Now it's time to take the LCM and simplify further. So if I take the LCM of x and 8 minus x, I get x into 8 minus x. The numerator would be 8 minus x plus x is equal to 8 upon 50. And in the numerator, minus x and plus x cancel. So I get 8 upon x into 8 minus x is equal to 8 upon 15. Again, 8 can cancel from both the numerators, and therefore both the numerators become 1. And therefore the equation is 1 upon x into 8 minus x is equal to 1 upon 15. Cross multiplying, I get x into 8 minus x is equal to 15. And therefore 8x minus x square is equal to 15, which means x square minus 8x plus 15 is equal to 0. This is the quadratic equation that I get. Now I need two numbers whose product is 15. So 15 is 15 ones are, but that doesn't give a sum of 8, or it is 5 threes are, and 5 and 3 definitely give a sum of 8, and it's negative 8. So negative 5 and negative 3. So this becomes x square minus 5x minus 3x plus 15 is equal to 0. So x into x minus 5 minus 3 into x minus 5 is therefore equal to 0, which means x minus 3 multiplied by x minus 5 is equal to 0, and therefore either x minus 3 is 0 or x minus 5 is 0. Now x minus 3 is 0 implies x is equal to 3 or x is equal to 5. So I have one case in which one part x is equal to 3, and therefore the other part is 8 minus x. So 8 minus x is therefore going to be 5. 8 minus 3 is 5. And in case x is 5, then 8 minus x will be 8 minus 5, which is 3. And therefore, the two natural numbers are 3 and 5. In both cases, you will notice that if one natural number is 3, the other is 5, right? Therefore, the two natural numbers are 3 and 5. Let's perform a quick check. 3 plus 5 is 8, so it definitely adds up. And if I take the reciprocals, so 1 by 3 plus 1 by 5, if I add them, I get 8 upon 15. Okay, that also matches the given condition, and hence my solution is right. Pausing again for a minute. Moving on to the next question. The difference between two natural numbers is 4 and the difference of their reciprocals is 1 by 8. Find the numbers. So now it's given that there are two natural numbers whose difference is 4. So I could take, let the two natural numbers be x, and the difference between both of them is 4. So I can take the second natural number as x plus 4. Of course, I could have also taken it as x minus 4, but in this case I have taken it as x plus 4. So now I know that this is the smaller number and this is the larger number. X plus 4 is larger. So x plus 4 is greater than x. And therefore, when I find the reciprocals, it's given that the difference of their reciprocals is 1 by 8. That means the reciprocal of one number minus the reciprocal of the second number, is equal to 1 by 8. Now the point of confusion or point of conflict right now is, should I write 1 by x as the reciprocal of the first number or 1 by x plus 4? That is what I'm trying to think about. Now because I have x plus 4 being the bigger number, when I take the reciprocals, definitely 1 upon x is going to be greater than 1 upon x plus 4, because x plus 4 is the bigger one. When I take the reciprocal of a bigger number, it is always going to be lesser. For example, I know that 10 is greater than 6. So when I take the reciprocal, so 1 by 6 becomes greater than 1 by 10, right? So in this case, because x is the smaller number, the reciprocal of x is going to be larger, which means 1 by x minus 1 by x plus 4 is going to be equal to 1 by 8. I will pause for a few seconds so that you can take a look at the formation of the equations and then we will move on. So now if we have to solve this particular quadratic equation, we first have to take the LCM. The LCM of x and x plus 4 is x multiplied by x plus 4. The numerator becomes x plus 4 minus x is equal to 1 by 8. X cancels and therefore 4 upon x into x plus 4 is equal to 1 by 8. So cross multiplying, I get 32 is equal to x square plus 4x, or the quadratic equation that I should be solving now is x square plus 4x minus 32 is equal to 0. Factorizing, I get x plus 8 into x minus 4 is equal to 0, which means x is either negative 8 or positive 4. Now the numbers are natural and therefore since the numbers are natural, we should discard x equals negative 8. Therefore, the only acceptable value for x is 4, and therefore the two numbers are 4 and x plus 4 is 4 plus 4, which is 8. So the two natural numbers are therefore 4 and 8. Pausing for a minute before I move on to the next question. Moving on to the next question. A two-digit number contains the smaller digit in the units place. The product of the digits is 24. Okay, so let the two-digit number be tens and units place. Let it be xy. So x is the digit in the tens place and y is the digit in the units place. It contains the smaller digit in the units place. So it is given to me that the smaller number is in the smaller digit is in the units place. So just to note, the digit in the units place is y. So y is smaller than x, right? This is given to me. The product of the digits is 24. That means the multiplication of these two digits, that is x multiplied by y, is equal to 24, which means I can say that y is equal to 24 divided by x, right? So now what I can do is, therefore, the two-digit number is, the tens place is x and the units place was y, but y has been replaced by 24 upon x. So therefore the two-digit number is now x and 24 upon x. These are the two digits that I have. And the difference between the digits is 5. So the difference between the digits is 5. So now we have to think about which digit is going to be greater, right? So now we have x and 24 upon x. So we have two conditions over here. Either x minus 24 upon x is equal to 5. That is one possibility. Or 24 upon x minus x is equal to 5. That is the other possibility. It's given that the difference is 5. It's not mentioned which one is going to be greater, right? So let us now consider both cases. If I cross multiply, I get x square minus 24 upon is equal to 5x. This is after taking the LCM, or rather I have multiplied the whole equation by x. Okay, and therefore it becomes x square minus 5x minus 24 is equal to 0. Factorizing x minus 8 into x plus 3 is equal to 0, which means x is either positive 8 or negative 3. Now if x is positive 8, x cannot be negative 3 because the digit cannot be negative. You will have to mention that. So x is positive 8, which means y is going to be 24 upon x. That's 24 upon 8, which is 3. And therefore the two-digit number is 83. Right? So does it satisfy both the conditions? The product of the digits is 24, condition satisfied. The smaller digit is in the units place, condition satisfied. And the difference between the digits is 5, condition is satisfied. So 83 is basically satisfying all the conditions. Let us now consider the second equation. So again, multiplying the whole equation by x, we get 24 minus x square is equal to 5x, which means x square plus 5x minus 24 is equal to 0. And therefore x plus 8 into x minus 3 is equal to 0, which means x is negative 8 or x is positive 3. Now x cannot be negative 8 because digit cannot be negative. So if x is 3, then y becomes 24 divided by 3, that is 8. And therefore the number that we are talking about is 38. So x is in the tens place and y is in the units place. Now over here it is satisfying the first condition, that the product of the digits is 24, that is being satisfied. However, the two-digit number contains the smaller digit in the units place. Now that condition is being violated, therefore 38 is not a possible answer, and therefore the right answer is 83. So this is how we solve this particular question. Pausing for a minute. Moving on to the next question. 9 times a certain whole number is equal to 5 less than twice the square of the same number. Find the number. So let the number be x. Let the number be x. Now let's take the conditions. 9 times a certain whole number, that is 9 times x, is equal to, that equals 5 less than twice the square of the same number. So twice of x square. That means 9x is equal to 5 less than 2 times x square. 5 less than twice x square basically means 2 times x square. And therefore 9x is equal to 2x square minus 5. Rearranging the equations, I get 2x square minus 9x minus 5 is equal to 0. So this is the equation that I am supposed to solve now, and therefore I can factorize the given equation. So I get 2x, x minus 5 and x plus 1 is equal to 0. And therefore 2x plus 1 is 0 or x minus 5 is equal to 0. So x is equal to minus half or x is equal to 5. Now it's a whole number, so as x is a whole number, x equals minus half is not allowed, is not permitted, and therefore x has to be equal to 5. So 9 times 5 is 45, is 5 less than twice the square. So let's check if this condition is true. 5 square is 25, 2s are 50, 50 minus 5 is 45, and the equation perfectly matches, and hence x equals 5 is the right answer. I will again pause for a minute, let you take a look at the formulation of the equation and the answer as well. Moving on to the next question. A 2-digit number is such that the product of the digits is 12. When 36 is added to the number, the digits interchange their place. Find the number. So again, this is a 2-digit number. So I would start off saying, let the 2-digit number be, there's a tens place and a units place. Let the tens place be x. And the product of the digits is 12, which means that the units place is going to be 12 upon x. Right? The product of these two digits, if you take the product of the digits, x multiplied by 12 upon x, xx cancels and you are only left with 12. So the product of the digits is 12. Now it's given that when 36 is added to this number, so this to this particular number, that is x and 12 upon x, if you add 36 to the number, the digits interchange their place. That is, the digits become 12 upon x and x, right? And therefore the equation that I can now build is, the value of this number is 10x because x is in the tens place, plus 12 upon x, that is in the units place, plus 36 is equal to 12 upon x is in the tens place, so its value becomes 12 upon x multiplied by 10 plus x multiplied by 1. Therefore 10x plus 12 upon x plus 36 is equal to 120 divided by x plus x. This x moves to the left side for subtraction, so 10x minus x becomes 9x. Then 12 upon x minus 120 upon x plus 36 is equal to 0. I can simplify these two terms because they have the denominator as x, so it becomes 9x minus 108 upon x plus 36 is equal to 0. Now I can multiply both sides by 9 and therefore, multiplying both sides by 9 makes no sense. I should multiply both sides by x, right? Why am I doing that? Because I want to get rid of this denominator. So 9x into x becomes 9x square, minus 108 upon x into x becomes minus 108, and 36 into x becomes 36x is equal to 0. Now I can divide throughout by 9. So dividing throughout by 9, what I get is x square minus 12x, minus 12, not x square minus 12 plus 4x is equal to 0, and rearranging I get x square plus 4x minus 12 is equal to 0. Factorizing I get x plus 6 into x minus 2 is equal to 0, which means x is either minus 6 or x is positive 2. Now the digit cannot be negative, therefore x equals 2 is the only acceptable value, and therefore the digits are, in the tens place there is x, in the units place there is 12 upon x. So if I substitute x as 2, then the tens digit is 2 and the units digit is 12 divided by 2. So 12 divided by 2 becomes 6, right? This digit becomes 6, and therefore the two digit number is therefore 26. Let's do a quick check. The product of these two digits is 12. Very good. The first condition is satisfied. When 36 is added to this number, that is when I do 26 plus 36, I get 62. The digits basically interchange their places, right? So 26 therefore satisfies all the conditions given in the question, and therefore it is the answer. Moving on to the next question. Moving on to the next question. The sum of the first n natural numbers is 231. Find the value of n. So the sum of the first n natural numbers, that means 1 plus 2 plus 3, so on till n natural numbers. This sum is given by 231. So we know that this is an arithmetic progression. Therefore, I can use the concepts of arithmetic progression. The first term in this arithmetic progression is 1. The common difference is also 1. And n is the number of terms that I have. So I know that the formula for Sn, the sum of natural numbers is given by n by 2 times 2a plus n minus 1 times d. So what are the different quantities that I know? I know Sn is 231 is equal to, n is what we are supposed to find, so n upon 2 times 2a, so 2 times 1 plus n minus 1 times d, d is also equal to 1. So therefore 231 becomes equal to n upon 2 times 2 ones are 2 plus n minus 1, and therefore 231 is equal to n upon 2 times n plus 1. This 2 is in division, it goes to the other side for multiplication. Therefore 462 is equal to n into n plus 1, which means 462 is equal to n square plus n, and therefore n square plus n minus 462 is equal to 0. So now we have to find the factors of 462, which is 231 multiplied by 2. Now 231 is divisible by 3, it becomes 77. So I have to multiply 2 by 3, it becomes 6. Let us now split 77 into its factors. 11 sevens are, and 6 also into its factors, 3 twos are. Now let's see if some combination over here gives me a sum of positive 1. I believe if I combine 7 and 3, it becomes 21, and combining 11 and 2, it becomes 22. Therefore, I want a sum of positive 1, which is positive 22 and negative 21. So therefore the splitting becomes n square plus 22n minus 21n minus 462 is equal to 0. So n bracket n plus 22 minus 21 bracket n plus 22 is therefore equal to 0, and therefore n minus 21 times n plus 22 is equal to 0. This implies either n minus 21 is 0 or n plus 22 is equal to 0, and therefore n is either 21 or n is negative 22. Now n cannot be negative here, you cannot have a negative number of natural numbers, and therefore n equals 21 is the valid answer, right? Therefore the value of n is positive 21. Pausing for a minute before I move on to the next question. Moving on to the next question. So let's take a look at the next question. A farmer wishes to grow 100 square meter rectangular vegetable garden. So this is the rectangular vegetable garden that he wants to grow. So let the length be L and let the breadth of this particular rectangle be B. So the length is L and the breadth of this rectangular garden BB. It's given that the area is 100 square meters. That means L multiplied by B is equal to 100. This is the first equation that is given to me. Now let's see what else is given. Since he has with him only 30 meters of barbed wire, he fences the 3 sides of the rectangular garden, letting the compound wall of his house act as the 4th side fence. So what he's doing is, he is only fencing 3 sides with the 30-meter wire. So let's assume that he is trying to fence these three sides. So he is fencing these three sides, and therefore the combined length of these three sides should be equal to 30 meters, right? Because we know that he is fencing only three sides. The combined length of these three sides is 2b plus L. This 2b plus L should be equal to 30. This is the second equation. And the compound wall of his house is acting as the fourth side fence. So his house is situated somewhere here, and the compound wall of his house is acting as the fourth side fence. Okay. So now these are the two equations, and we have to now find the dimensions of the garden. That means you have to solve for L and B. These are the two equations. Now these are simultaneous equations because we have to find the value of L and B, which is satisfied by both the equations. So from equation 2, I can say that L is equal to 30 minus 2 times B. And substituting this value of L, substituting L equals 30 minus 2B in the first equation, what I get is 30 minus 2B multiplied by B is equal to 100. So 30B minus 2B square is equal to 100, which means 2B square minus 30B plus 100 is equal to 0. Now dividing throughout by 2, we get B square minus 15B plus 50 is therefore equal to 0, which means B minus 5 into B minus 10 is therefore equal to 0, and therefore B is either positive 5 or positive 10, right? So the breadth is either positive 5. So let's take the first case. So in the first case, B is positive 5. Then the length can be calculated. So length will be 20 in that case, right? And in the second case, in case 2, B is 10, and therefore L is also going to be 10. So these are the two possibilities that we have. So in one possibility, we have length and breadth both being equal to 10, but that makes it a square garden. And in the second case, we have B equals 5 and L equals 20. So the dimensions of the garden are 5 meters, 10 meters by 5 meters, length by breadth, or 20 meters by 5 meters. When the breadth is 5, the length is 20. So 20 meters by 5 meters or 10 meters by 10 meters. Now, these are the two possible solutions that we have. Let me again pause for a minute while you take a look at the solution. Moving on to the next question. Let's take a look at the following question. A chessboard contains 64 equal squares and area of each square is 6.25 square centimeters. A border around the board is 2 centimeter wide. So there is a border around the board which is 2 centimeter wide. So this particular length that we have, this is 2 centimeters on all sides. It's given that we have to find the length of the chessboard. So we have to find the complete length over here, right? This is the complete length that we have to find. So I'm going to pause for a minute and let you take a look at this question and see if you can figure out the right way to solve this particular question. So let us assume that the total length of the chessboard is x, right? Let's start with this assumption. Let the length of the side of the chessboard be x. So you will notice that the inner length that I have over here, that is this particular length, is going to be x minus 4, because from both sides the whole length is x and I have subtracted 2 and 2 from both sides. Therefore the inner length becomes x minus 4. Therefore the inner length of the chessboard, or just the length of the squares combined, is basically x minus 4. Now each square, there are 64 such squares, therefore this is going to be, each square has an area of 6.25, and therefore the total area of chess squares is going to be 64 multiplied by 6.25, and that's basically going to be 400 square units, right? There are 64 chess squares and each square has an area of 6.25. So the combined area is going to be 64 multiplied by 6.25, and that is going to be 400. And therefore I can say that the area of the inner square is x minus 4, the whole square, that is going to be equal to 400. And this is now a quadratic equation that we can solve. Now I am not going to open up these brackets, rather I am simply going to take the square root of 400, and x minus 4 is therefore equal to positive 20, or x minus 4 is equal to negative 20, which means x is either 24 or x is equal to negative 16. Now x cannot be negative because it is the dimension of the chessboard, and therefore the length of each side of the chessboard is going to be 24 centimeters, right? This is the length of each side. So this is where we end our session over here, and I'm going to pause for a minute, let you take a look at the solution, and I hope that you understood the quadratic equation word problems that were solved today. Ending today's session here.